All right, beautiful people, this is Thursday, so we're starting out with 1/5 divided by 2. And you guys know I have zero talent for dividing circles, so I'm instead going to 1, 2, 3, 4, 5. I'm instead going to just draw a rectangle. So I have 1/5, this is me, and I'm dividing it by 2. So I work this whole thing up. So how much, in my model, how much is each section worth? This is 1 of 10, this is 1 of 10, 1 of 10, 1 of 10, 1 of 10. If I start out with 1/5 and I share the 1/5 with 2 people, each person will get 1 of the tenths that this creates. Now how we do that with numbers, we convert this whole number to a fraction, and then we keep, change, and flip, finding the reciprocal of the second fraction, or the divisor. 1 times 1 being 1, 5 times 2 being 10. That's our answer. Number 2, Tom has to walk 3/8 of a mile to school. If he walks 4/5 of the way, how far has he walked? So, Tom has to walk 3/8 of a mile. He has walked 4/5 of the 3/8. So we learned in topic 8 that of means that we multiply. So I'm going to move over because I'm writing way too big. So 4/5 times 3/8. And then we will multiply from there. 4 times 3 is 12, and 5 times 8 is 40. And when I look at these two numbers, I notice that this is in the 2, this is a 0, these are even. Let's see, I'm going to come here and do this. So I will simplify this. Starting out with 2, 12 divided by 2 is 6. 4 divided by 2 is 20. And then they are still both even, so I'll divide them by 2 again. 6 divided by 2 is 3. And 12 divided by 2 is 10. And now I've got a fully simplified answer, okay? Number 4, we'll skip number 3 and come back. Number 4 requires us to convert improper fraction to a mixed number and a mixed number to an improper fraction, which you guys are all professionals at this point. We know first one to the party gets in the house. One group of 6 will fit into 7 with a remainder of 1, and we read it like a clock. So 1 whole and 1/6. Here we will multiply. 2 times 6 is 12, plus 5 is 17/6. All right, number 5. Take a little time to think about number 5. So with number 5, we are dividing, and we're dividing, again, looking at these powers of 10. So 10 to the second power, we be dividing by 100. 10 to the second power, we be dividing by 1,000. All right, so putting this into the standard algorithm, because there is a simple trick for this, but I think seeing it will really help. Can't divide 7 by 10, but I can divide 74 by 10. 74 divided by 10 is 7, because 7 times 10 is 70. With a remainder of 4. Once I get here, I've got to get rid of this remainder. So I add a decimal, raise it to the roof, add a 0, bring it down. 40 divided by 10 is 4, and 4 times 10 is 40. So 74 divided by 10 is 7 4/10. Now we're going to divide 74 by 100. And what we're looking for is a pattern. 7 divided by 100, can't do that. 74 divided by 100, I can't do that. So what I have to do is put in a decimal, raise it to the roof, add a 0, and now I'm ready to do something, okay? And actually, let me be a good teacher. That's 0. This is 0. Sorry. All right, okay, and that would be 74. So then I put this 0 in, drop this down. Now I'm at 740 divided by 100, which is 7. And then 7 times 100 is 700. And then I have 40 left over. When I subtract, I add another 0, bring it down, and now I have 400 divided by 100, which is 4. And 4 times 100 is 400, and then we 0 out. So 74 divided by 100 is 74 hundredths. So now thinking about that, where do we predict? What is happening with this decimal? What do we see in the pattern? So before we predict, or after now that we predicted, let's just put this in the standard algorithm so we can see it. So I've got, that's going to be 0, 7, bring this down, 74, that will also be 0. 0 times 1,000 is 0, 74. Here we're at the end, so we're going to add a decimal, raise it to the roof, add a 0, bring it down. 740 divided 1,000 is also 0. 1,000 times 0 is 0. So we're here with this remainder, so we just keep adding a 0 and we bring it on down until we are where we need to be. So 7,400 divided by 1,000 is going to be 7, and 7 times 1,000 is 7,000. And then our remainder will be 400, and we would add a 0 and bring that 0 down. And now we have 4,000 divided by 1,000, which is 4. And 4 times 1,000 is 4,000, and then we 0 out. So if you predicted that the decimal was going to move one more time, you are correct. And so what we see here is that when we divide 74 by 10, we move this decimal up one time. When we divide 74 by 100, we have 2 zeros, so we move this decimal from the end of 74 up 2 times. When we divide by 1,000, we would move it 1, 2, 3 times. Why? Because there are 3 zeros on 1,000, okay? Now, on the other side, when we're doing this with the decimal, it actually moves in the other direction, and I just want to show you guys why, because this was a bit of a disastrous unit for us with everything going on with the strike. So here, we have 1/10. When we divide decimals, we move it, invisible decimal, move it, raise it to the roof, that becomes a 0. Now we have 740 divided by 1, which is 740, because any number divided by 1 is that number. So same thing, we have start out with 74 divided by, this time, 100, and we have to get this decimal to the very end. So when we divide decimals, we move it. We moved it twice here, so we write our invisible decimal in, we move it twice here. Raise it to the roof, fill in our zeros. Now we have 7,400 divided by basically 1. And that's going to be 704,000. So same thing, this one, starting off with 74, dividing it by 1,000. We've got to move this decimal all the way to the end. So 1, 2, 3, moved it 3 times there. We got to move it 3 times here. So 1, 2, 3, raise it to the roof, our zeros. And now we're basically looking at 74,000 divided by 1, which is going to be 74,000. So what just basically happened in the pattern with this number is that our decimal, this is almost like we're to a certain extent multiplying. Our decimal is just moving to the back of this number. So there's 1 digit behind the decimal, so we move it back and fill in the 0. There are 1, 2 digits here, so we move it 1, 2, fill in the 0. 3 digits behind the decimal, 1, 2, 3, and fill in with zeros. So that's the pattern. Last one, number 3. Add parentheses to make true. So this is kind of like a try and see type thing. So they've given us this nice little number here. And we need to be thinking about, please excuse my dear Aunt Sally. Okay? So what we're going to do, knowing that parentheses requires us to do this first, I'm going to write the expression out, and I'm actually going to try to use a pencil here so that I can erase if I need to. And we're just going to try things out to see how they work, right? So I'm going to start out putting the parentheses around 3 times 18. So multiply this, and that's going to be 54, right? So 54. And then we're going to drop down everything else we haven't used. Now, the way this works, we've got to look at it and go from there. So we did parentheses. We don't have exponents. Next, we would multiply or divide. So from left to right. So 54 divided by 6, that's going to be 9. So we did that. And now we did this. So we'll drop down this part. And then 9 plus 5 is 14. So that makes it true. If we put the parentheses somewhere else, this would not have equaled 14. So we have to make sure we do that correctly. So case in point, what I mean by that, let me try it another way so you guys can see what I'm talking about. If I did another operation first, it would have changed the answer. So 6 plus, let's say I put here, 6 plus 5, that equals 9. I'd work with that. That does not equal 9. Sweet baby Jesus. 6 plus 5 equals 11, sorry. So I work with that. I'm going to drop down everything else I didn't use. And then according to the order of operations, I would come back. Let's see, multiply would be next. So 3 times 18 would be next. So that would be 54. And then I would have to divide 54 by 11. And I am here to tell you that 54 divided by 11 would not equal 14. So where you place the parentheses really does matter.